1 billion. There is a huge possibility that Mars's population will be as large as that of Earth's one day. In fact, with 8 billion people milling the streets of Earth today, it would be preferable to live on a much more organized planet, Mars. At least, it will be in 100 more years. That said, when will we get to start migrating to Mars and start a civilization there? How will we go there? More than that, how will we thrive on Mars? Well, on Mars, there's extra time in the day to get things done, or more importantly, rest. Martian days are about half an hour longer than Earth days. However, that could be a disadvantage as well, since instead of only 365 days on Earth, it's equivalent to 687 days on Mars. Still, the question is, how will we get there? Since the 19th century, the idea of living on Mars has been pure science fiction. However, through the years, it became apparent that it was actually a possible occurrence, although not anytime soon. Still, it was a start. In 1965, NASA's Mariner 4 spacecraft completed the first Martian flyby. The spacecraft launched on November 28, 1964, and was the first to fly by the planet on July 14, 1965. It sent 21 photos of its target back to Earth.
And it took 22 pictures of Mars. What do the pictures mean to Dr. Layton?
2 days after Mariner 4 launched, the Soviet Union tried again with Zond 2. Although the spacecraft passed by Mars, its radio failed and didn't return any planetary data. There were no more missions after that until 1969, when the US launched Mariner 6 and Mariner 7, both of which reached Mars and sent back a few dozen photos, according to NASA JPL. All of these spacecraft happened to fly over areas of Mars that were covered in craters, giving astronomers the false first impression that Mars looked like the Moon. Several more attempts were made between 1969 and 71, but most failed to reach their target. 6 years after the first spacecraft flyby on Mars, the Soviet Union's Mars 3 lander became the first spacecraft to land softly on Mars. It was launched on May 28, 1971, and arrived on the Red Planet by early December of the same year. Unfortunately, it was lost nearly immediately thereafter. Still, while the lander worked for only a few seconds on the surface before failing, the orbiter remained operational.
We land in the late afternoon on a Martian day, and within seconds after the landing,
then, in November 1971, the public's image of Mars changed with the arrival of NASA's Mariner 9. The spacecraft, which launched on May 30, 1971, arrived at Mars when the entire planet was engulfed in a dust storm. It was then that scientists discovered unusual features which turned out to be the tops of dormant volcanoes.
When Mariner 9 was placed into an orbit around Mars, it saw a planet 1/2 the size of Earth, blanketed by a gigantic dust storm.
Since then, there have been numerous successful missions to the Red Planet, including the deployment of 4 Mars rovers and NASA's Mars Odyssey spacecraft, which produced a map of the entire planet. Overall, there's a long list of Mars missions recorded, both failed and successful missions. Simply put, NASA spent more than 4 decades on their journey to Mars with wildly successful robotic explorers. The first human steps have been taken through science and technology research aboard the International Space Station, or the ISS, and in laboratories here on Earth. On that note, NASA believes that they're closer to sending humans to Mars than at any point in NASA's history. It can be done by journeying in phases. NASA laid out 3 phases on our journey to Mars. The journey to Mars passes through 3 thresholds, each with increasing challenges as humans move farther from Earth. NASA and its partners are managing these challenges by developing and demonstrating capabilities in incremental steps. The first phase is Earth-reliant. It's an exploration focused on research aboard the ISS. On the space station, NASA's testing technologies and advancing human health and performance research that'll enable deep space long-duration missions. The next phase is Proving Ground, where NASA will learn to conduct complex operations in a deep space environment that allows crews to return to Earth in a matter of days. The final phase is Earth-independent, where activities build on what NASA learned on ISS and in cislunar space to enable human missions to the Mars vicinity, including the Martian's moon and eventually the Martian surface. In light of that, future Mars missions will represent a collaborative effort among NASA and its partners. It is notably a global achievement that marks a transition in humanity's expansion as we go to Mars, not just to visit, but to stay.
This system is capable of being the catalyst for deep space missions that can support humans from launch
through deep space and return safely back to Earth.
To attain this goal, we'll need the help of SpaceX, a company co-founded by tech mogul Elon Musk. You want to wake up in the morning and think the future is going to be all great, and that's what being a spacefaring civilization is all about, Musk said. It's about believing in the future and thinking that the future will be better than the past. And I can't think of anything more exciting than going out there and being among the stars. Because of this vision, he's working hard to make sure that the succeeding Mars missions will be successful. In fact, SpaceX's Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, represent a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. Starship will be the world's most powerful launch vehicle ever developed, capable of carrying up to 150 metric tons fully reusable and 250 metric tons expendable. Together, the Starship spacecraft and Super Heavy rocket create a reusable transportation system capable of on-orbit refueling and leveraging Mars's natural H2O and CO2 resources to refuel on the surface of Mars. For its very first Mars missions, SpaceX will land at least 2 uncrewed cargo ships on the Red Planet before sending any humans there, according to Paul Wooster, the principal Mars development engineer at SpaceX. Those cargo missions would bring supplies such as life support systems and power generators that the first astronauts on Mars would need when they set up camp. After those first 2 cargo missions, SpaceX will launch 2 crewed missions alongside 2 additional cargo-only flights to begin setting up a propellant production plant. At that plant, water and carbon dioxide will be converted into liquid methane and liquid oxygen, which fuel the rocket's engines. So, while SpaceX intends to set up a transportation system for humans and cargo traveling to the Red Planet, the company won't be building an entire Mars base on its own. Musk has laid out its own vision to create a 1 million-person colony on Mars, but to establish that colony, SpaceX will have to work together with NASA and the agency's international partners and other commercial space companies. Now that we know how we'll get there, we need to know how we'll thrive on Mars once we're there. That said, we should be aware of the challenges we may experience. Basically, there are vast differences between life on Earth and Mars. Mars's atmosphere is carbon dioxide based. Moreover, the planet's atmosphere is 95.3 carbon dioxide. And without a magnetic field, its surface is bombarded by the sun's radiation. Its thin atmosphere cannot block ultraviolet radiation from space, which would devastate any known living thing on the surface of the planet. Additionally, Mars's surface is rock and dust, while Earth's surface is 70% water. That said, we can expect to experience extreme temperature shifts between seasons more than we do here on Earth. Despite all these, Mars is an excellent place to investigate because it's the most similar planet to Earth in the solar system. On that note, here's what you can expect in a futuristic Martian city.